Hello, this is Mr. Precella, and today we're going to be setting up some word problems involving linear systems of equations. And once we've set them up, then I'll leave it up to you to decide how you want to solve them, by substitution or elimination. We've already discussed those in class. Or if you want to use matrices, or there's a lot of websites, apps out there that can solve system of equations. But the purpose here is to just practice setting them up, and I'll leave it to you to finish solving it. Now, here's the first one we're doing today. A basketball player scored 22 times during one game. She scored a total of 41 points, 2 for each 2-point shot and 1 for each free throw. How many 2-point shots did she make, and how many free throws? So we want to know how many 2-point shots and how many free throws. So there's two unknowns. I'm going to go ahead and identify the variables like this. I'll let X be the number of 2-point shots, and Y will be the number of free throws. Now, since we have two variables, we need two equations. Well, the first statement, she scored 22 times during her game. That means that the number of 2-point shots plus the number of free throws should equal 22. So I'm just going to do this, trying to summarize the data there. So this is giving me one equation, X plus Y equals 22. And then we're told she scored a total of 41 points. Well, let's make a points column. The 2-point shots, well, she got 2 points for each one of them. And for the free throws, she got 1 point for each free throw, with a total of 41 points. How do we get a second equation now? Well, she got 2 points for every 2-point shot. Okay, if she threw 10 of them, then she got 20 points from the 2 points. So 2 times X plus 1 times Y, or just Y, equals 41. So there's your two equations, and you can solve it however you want. I'm just going to set it up. Maybe for this first one I'll go ahead and go through and solve it. But did y'all see how I got the second equation? For every 2-point shot, she's getting 2 points. So 2 times X. For every free throw, she's getting 1 point. 1 times Y. Altogether, she got 41 points. So if we wanted to solve this, maybe I think what I'll do is solve it by elimination. And perhaps the best way to do that would be just to multiply this top one here by -1. I'm using elimination. If I went through and multiplied this top equation by -1, I'd have a negative X, a negative Y, and a negative 22. Now, if you wanted to multiply the bottom one by -1 instead, that would be fine. You'll still get the same answer I'm getting. Notice how the y's are being eliminated. Negative y plus y when we add vertically. Negative 1x plus 2x is a positive 1x equals negative 22 plus 41. What's that going to be? Is that a 19? So altogether, she made 19 2-point shots. How do we figure out the number of free throws? Well, take this number and plug it into one of these equations. Probably it's easiest to plug into the first one. If I put a 19 in for x, I would have 19. I'm plugging this 19 in for x. So we'd have 19 plus y equals 22. So altogether she made 22. She scored 22 times. 19 of them were 2-point shots. That means that the remainder has to be 1-point shots. How many are remaining if she scored 22 times total? Well, 3. Well, if you want to do it algebraically, 3. Okay. So all of these, once you've got them set up, solve pretty quickly with either elimination or substitution. And I only have time to set up the rest of these. So that's what I wanted to do. Set them up. Let's see. Here's the next one we're going to do. A woman bought some large frames for $12 each and some small frames for $9 each at a closeout sale. If she bought 16 frames for $159, how many of each type did she buy? Well, I'm going to set this up the same way I did the other one. I'll let X be the number of large frames. Y is the number of small frames. Altogether, she bought 16. Now, let's look at the other information. That would be the cost column. The large frames cost $12. The small frames, $9. And what's that total there? She bought 16 frames for $159. Oh, y'all see the two equations? Very similar to that one we just did. We'd have x plus y is 16 and 12x, $12 for every large frame. So if she bought, I'm just randomly choosing a number 10 large frames, then she would have spent $120. 12 times 10 plus 9 times y equals 159. If I do this quickly, I can go ahead and solve it by elimination. I could either multiply this top by negative 12, or I could multiply it by negative 9. I think I'm going to multiply by negative 9. If you want to use substitution, that is certainly fine. We would have a negative 9x minus 9y equals 16 times a negative 9. That's a negative 144. So let me recopy the second one. And let's add vertically. The negative 9 plus 12 is 3, so we have 3x. Notice how the y's are subtracting out, equals negative 144 plus 159. Let's see, that is a 15. So divide both sides by 3. And she didn't buy a lot of those large frames. She bought 5 large frames. X is 3. And either plug in the 5 or just use your, I hate to say common sense. It says she bought 16 frames. 5 were large. That means the other 11 have to be small. Okay. Y'all see how I did that? If you want to just plug in 5 plus y equals 16 and solve it for y, you're still going to get y equals 11. So moving on along. The cost to attend a movie is $8 for adults, while children are admitted for $5. If a movie was attended by 62 people who paid a total of $352, how many adults and how many children attended the movie? Well, let's see. I'm going to write it out the way we've been doing it. So I'm going to let X be the number of adult tickets. Y is the number of children tickets. Now we have a cost column, or price, whatever we want to call it. It costs $8 for each adult and $5 for each child. Hopefully you're seeing these are all sort of similar. They're set up in a similar way. Altogether there were 62 people who paid $352. That 62 is the sum of X and Y. And 352, that would be the total price, or the total amount of money they brought in. The theater's charging $8 for every adult ticket and $5 for every child ticket. So if 10 adults went, then 8 times 10, that would be $80. But I just randomly made that up. So let's see. What are the two equations? X plus Y equals 62, and 8X plus 5Y equals 352. If you can read my mind, if you know what I like to do, I prefer elimination over substitution. So given a choice, that's what I'm going to do. I could either multiply this top equation by -8, or I could multiply it by -5. I think I'll multiply it by -5. So we'd have a -5x minus 5y equals negative, what's that going to be? 300 plus 10, 310. Now let me recopy this. It's going to fall out real quickly when I add vertically. Notice how the y's are being eliminated. -5 plus 8 is a positive 3. -310 plus 352 is a 42. That's easy to solve. Divide by 3. 42 divided by 3, is that 14? So altogether, there were 14 adult tickets sold. Well, if X plus Y is 62, plug in that 14 in for X, we'd have 14 plus Y is 62. So if there were 62 tickets sold altogether and 14 of them were adult tickets, then that means that the remaining have to be the children tickets. 62 minus 14, is that a 48? So there were 48 children's tickets and 14 adult tickets. If you want to check and make sure that you've got the right answer rather than just punching it in, you could get out your calculator and see, are you getting 352? If I go 8 times 14 plus 48 times 5, is that giving me 352? It certainly is. Okay? So you could have checked all of the ones we've done like that. Let's see, here it says use Gaussian elimination. That's the matrices with the ones and zeros. I think I'll just continue using my elimination for it, okay, rather than writing out the matrices. If you want to use the matrices or some app, of course that's up to you. The point here is to be able to set these things up. So Mike works a total of 58 hours per week at his 2 jobs. I guess that's just a, sad state of the world right now. He makes $7 per hour at job A and $8 an hour at job B. If his total pay for 1 week is $428 before taxes, then how many hours does he work at each job? Well, we want to know how many hours he's working at job A and how many hours he's working at job B. So let's go ahead and identify the variables. X would be the number of hours at job A, and Y is the number of hours at job B. He works a total of 58 hours a week, so hopefully you're getting the hang of this. That would be the total of X and Y. And then we have this money column. He makes $7 an hour at job A and $8 an hour at job B. His total pay for 1 week is $428. So what are the 2 equations? Well, X plus Y is 58. And if y'all got the hang of it, what's this one going to be? It'd be a 7X plus 8Y equals 428. He's getting paid $7 for every hour he works at job A. He's getting paid $8 for every hour he works at job B. Okay. So 7X plus 8Y. Oh, let me see. I think we have time to go ahead and finish this one up. I was just going to set them up, but I'll do it with elimination. If you want to write out the matrix, okay, I'll leave that up to you. I'm going to multiply this top row by -7, and you might wonder, well, why not do -8? Well, I could do -8, but then I'm going to wind up with a negative X that I have to get rid of. If you look back at what I've done on all of these, I always chosen in such a way that I didn't have the negative to worry with. So multiplying by -7, I do -7X minus 7Y equals, let's see, what's 58 times -7? Well, 50 times 7 would be 350 plus 56, that's a 406. Now let me recopy that second equation. And I will add vertically. Here the x's are being eliminated. -7 plus 8 is a +1 y. -406 plus 428, let's see, 428 minus 406, is that a 22? So we got the number of hours at job B first. So he's worked 22 hours at job B. So if he worked a total of 58 hours, if Y is 22, most of you can do this without having to use any algebra. You know, okay, you worked a total of 58 hours. You worked 22 hours at job B, so the remaining have to be job A. So what's that going to be? 58 minus 22. Is that 36? So if we want to check it, let's make sure we're getting 428. 36 and 22 definitely add together to give a 58. But what about the 428? Let's see. He's working 36 hours, making $7 an hour. He's working 22 hours, making $8 an hour. Is that giving 428? Yes, it is. Okay. So, yeah, we got all of those done. I was just going to set up the problems, but we set them up and actually solved them pretty easily with elimination. Again, you could have used any method you wanted. Elimination for 2x2 linear systems, that's my favorite method. Okay, if you wanted to use the matrices, Gauss-Jordan elimination, you could do that. I can't imagine why you'd rather do that than just plain old elimination, but at least that's my preference. But that is it, and thank you for watching, and I'll see you in class soon, maybe. Bye-bye.